line infrastructure system. And I'm going to just turn to a presentation developed in Italy with respect to electrification and power supply, and get into electrification in a little more detail. The railway power supply in Europe has a high standard of interoperability. And when you see that they're concerned about interoperability, which means simply that trains can move across country borders from one system to another, you know that in Europe there is not a single standard of electrification. So we're going to talk about the Italian high-speed line as an example, and we're going to touch on the fact that not only does power have to be supplied to trains for train operations, but the signaling system is also is required to be powered by the system. So railway power supply is an integrated system. You have the high voltage power lines coming into the substations feeding the contact lines over the railroad so that the train with its pantograph can draw power and operate. And then there's a command and control system which controls the electrification system that is available to the operators. And very often the command and control system is integrated, so you see operations and traction power at least in one room, and sometimes in one set of display panels. So we are talking about Europe, which has a very high proportion of all of its railroading, freight and passenger, conventional and high-speed, electrified. This is very different than in the United States, where we mostly run diesel-powered trains. And that's going to be a disturbance. Take that off. So in a nutshell, the electrical system has a greater power to locomotive weight ratio, so you can generate more power per pound of locomotive. You certainly have environmentally an improved reaction from the power. Most electricity is drawn from power plants that are have great environmental controls. There are no moving generators of pollution. The locomotives themselves have lower maintenance costs, and they have better acceleration and deceleration characteristics, so that greater commercial speeds can be generated with the same maximum speed. In Europe, this is a map that shows the different electrification systems, and you can see there are 5 or 6 of them being displayed, and so we can conclude that there is no standard European electrical system, but interoperability means that the train equipment that is produced and used to run passenger trains is capable of moving across these boundaries without without hesitation. So the electrical systems just immediately change. For high-speed lines, primarily there's the 25 kV in France, Belgium, Spain, and Italy, being supplied directly from the high-voltage national provider through the substations. But in Germany, they have a 15 kV, 16 2/3 hertz system, which is different, but trains can move across that border without any hesitation because of the design of the systems. The design criteria relates to the power collection and voltage, so that it is very stable for the trains. The mechanical interaction between the contact line and the pantographs at the speeds that the trains are operated must be very precisely maintained. Reliability of the power system is as important because it drives the reliability of the whole train system. And then the design of the power system needs to take into account maintainability and management of the electrical installations. So here's a diagram of the power absorbed by the train and the calculation of voltages, stability being so important. A rather poor picture of the integration of the catenary and the pantograph. That pantograph is touching the catenary at all times. The catenary is designed to move across the pantograph, so it's somewhat staggered slowly so that the wear of the pantograph is even across the carbon strip that's in contact with the wire. High degrees of reliability need to be guaranteed for normal operations, and one way to do that is redundancy. So if one substation for any reason goes down, power can be fed to that segment of line from one or more other substations. The maintainability and management gets back to the control center, where the displays include all of the electrical power situations, the stability of the voltages, the feeding of the substations and substation status, as well as the continuity of the lines and the issues of tension in the lines. The Italian supply system at 25 kV has the advantages of being able to power high traffic trains with high density, in other words, many trains per day. And because of the design of the system, they are able to make sure there are very few voltage drops and less environmental impact. So they have substations about 50 kilometers apart. They have auto transformers about 12 kilometers apart, and the contact wire specifications are here described. Now, in addition to that, the signaling system needs to have power supply to it. It's a separate power system. It's also displayed in the control center. Every shelter which contains signal system equipment is powered by 1,000 volt lines, and its maintainability and its continuity and its reliability is very, very important.